This off-site testing of the lifting procedure for preform modules made by CrownHouse and destined for the T2 building at Heathrow is of course a simulation. We're not working at height, site conditions are not as busy as they would be, and the work is being done in an open area. But the principles for the lift are the same.
Well, these are the preform modules made by CrownHouse. We bolted them all together, we lift them off the lorries, then we put them all together on a level ground. Once it's all bolted together, once we've got 3 modules bolted together, we then attach the lifting tackle. And as you can see from here, we've got, just for test purposes, we've got 4 or 5 ton strops going on to 5 ton snatch blocks. Each snatch block has a wire bond running through it that makes up an 8-point lift throughout the module. So theoretically we've got equal strain on all lifting points. On this particular module, because of the way it's been constructed, we've added some extra links in it on one end, on the opposite end to the AHU. It's just a wee bit lighter, so we've added extra links in that, and it picks up perfectly level. Once we've got it level, we're satisfied that we're going to lift. We position 4 skyjacks up against the tower, and then the idea is we hoist them up to the level, which, as I say, is going to be about 28 metres. And then we instruct the crane to lift the module up, slew over the top of the shaft with tag lines and anything else necessary to stop it spinning in the air. Wind is going to be a bit of a problem, so we're hoping for good conditions. But all operations we've done very, very slowly. We'll get it up to the shaft, get it hovered over above the shaft. Then what we'll have is 4 people up on the cherry pickers, up on these radios, only one of which will be controlling the crane. The other 3 will be crash radios, so that we can understand what's going on around the shaft at any one time, because obviously we're working blind. Once we're satisfied that we're ready to lower it down into the shaft, the main banksman will be instructed to lower the crane off down through the shaft. We've got a bit more clearance than we thought we'd have. We've got about 120 mil each all the way around it. At first we thought we was going to have about 50 mil to spare. We've got a lot more than that, so it shouldn't be too bad. But we have got to be careful because of the lattice work construction of the shaft that we don't catch up in anything. Once we reach our correct level, we then stop the crane. Obviously the skyjacks are following the module down as it's lowered down into the shaft. Once we've found our level, we then have to fix on the stabiliser legs. And then it then sits onto the side of the module, which then sits onto the structure of the shaft. And it just sits down square on. The legs that we have to bolt onto the side are heavy, so we might have to have a look at another way of doing that. We've suggested a little chain block on the side of the module to support the weight of the leg, so we can then line up the bolts. Okay, just for simulation purposes, we can only sort of demonstrate this from a simple point of view. We're standing on the ground obviously, but bearing in mind we'll be 100 feet in the air. When we've arrived at height, these lifting legs will be brought up in the cherry picker. We then place them on the steel work as we go up, and then we secure them with a fine wire, secure wire, so they can't go anywhere. Then we'll attach a chain block further up the steel, just attached with a webbing sling. It's only a light chain block, it doesn't need to be anything heavy. We'll then attach another webbing sling onto the handle of the leg. Attach the hook. We can then hoist it up to whatever level we require. But first and foremost, we hoist it up just to locate these bolts. Then lower it off, and then it's safe. It can't go anywhere at all. We can then make fine adjustments to line up the bolts, and as I say, this will be a 2-man operation anyway, one to operate the chain block and one to put the bolts in, but it's a safe system of work. The reason for it is fine working on the ground as we are, but for simulation purposes we will be actually working near enough a metre away from it. An arm stretch, something that weighs 30 or 40 kg, was absolutely no chance at all. It's dangerous, unsafe, and possibly, nearly impossible, I would say. Another way of dealing with the support leg problem that we discussed earlier is CrownHouse have come up with another system whereby it's The actual leg is mounted on a sliding system on the structural steelwork. When the module arrives at its correct height, this leg is then slid out and then bolted in place. But actually this is all part and parcel of the structural steelwork. So that's an even better idea. Doesn't involve any manual lifting or anything like that, and possibly could be a lot easier to use.
The second module is lifted in the same way as the first. The same tackle is being used to get an even lift. On site there will be 4 sets of 6 blocks per riser, and this is one of those 6 blocks. The difference here is that the module isn't resting on support legs. Instead, once the tackle has been taken off the first block, spigots are put in place to take the second module. Of course, the top module has to line up perfectly to fit into the spigots, and this one does.